Bismillahirrahmanirrahim. Assalamu alaikum my dear students. I hope you all are doing well. I warmly welcome you all in our lecture 4 part 2. Before moving forward, those who are watching this video for first time, I want to mention here that in lecture 4 part 1 we discussed some easy tricks to write electronic configuration of all elements present in periodic table. Trick 1 was writing electronic configuration of elements with the help of this poem. And if we talk about trick 2 was just writing the orbitals S, P, D and F and assigning them some numbers like 1, 2, 3 and 4. After knowing these two tricks, we were able to write electronic configuration of all elements present in periodic table, but how we wrote their electronic configuration? To know that, you need to go back and check our lecture 4 part 1. Today, I am going to discuss some exceptional cases in periodic table, and for those exceptional cases we cannot apply these two tricks because their electronic configuration is little different as compared to the electronic configuration of other elements present in periodic table. Let us talk about the number of exceptional cases in periodic table. There are 13 exceptional cases, and in this lecture we will know about what are those exceptional cases with their atomic numbers. Number 2, what is the reason behind their change electronic configuration as compared to the electronic configuration of all other elements present in periodic table. And number 4, how we can write their electronic configuration. First of all, have a look at these exceptional cases. Number 1 is chromium, atomic number 24. Number 2 is copper, atomic number 29. Niobium, atomic number 41. Then molybdenum, atomic number 42. Then ruthenium, atomic number 44. Then rhodium, atomic number 45. Then palladium, atomic number 46. Then silver, atomic number 47. Lanthanum, atomic number 57. Number 10 is cerium, atomic number 58. Number 11 is gadolinium, atomic number 64. Number 12 is platinum, atomic number 78. Number 13 is aurium or gold, atomic number 79. These are the 13 exceptional cases whose electronic configuration is changed. Before discussing electronic configuration of chromium, let us have a look at the electronic configuration of silicon. And we were supposed to write electronic configuration of silicon with the easy way with the help of trick 1 and 2. In silicon, atomic number is 28. So we are supposed to distribute the electrons. In S there would be 2 electrons, 2s2 electrons, 2p6 electrons, 3s2 electron, 3p6 electron, 4s2 electron. In 3d there would be 8 electrons. Okay students, keep it in your mind that silicon is not an exceptional case. We just followed this pattern of filling electrons and filled all the 28 electrons of silicon in orbitals. Right? If we will look at the exceptional case, that is chromium, and distribute 24 electrons, the distribution of electrons will not exactly like the electronic distribution we observed in silicon. Before writing the electronic configuration of exceptional cases, just remember that in exceptional cases D subshell would be there, and if D subshell would be there, write the correct electronic configuration. D subshell should be either completely filled or either partially filled, leaving behind no electron for s orbitals or 1 electron for s orbital. How? Partially filled d orbital means, as we know that d orbital shows 5 orientations that are dxy. Orientation number 2 is dzx. Number 3 is dyz. Then dx square minus dy square, and then dz square I, I wrote it down by giving some space, but it's one orbital with 5 orientations. Now partially filled d orbital means if one electron in each kind of orientation, like one electron in xy, one electron in d zx, one electron in d yz, one electron in dx square minus y square, and one electron in d z square. It means now d orbital is partially filled. And completely filled means having 2 electrons in each orbital. This is the completely filled state of d orbital. Keep it in your mind that electronic configuration of exceptional case would be correct if the involved d orbital would be completely filled or partially filled. Now let us have a look at example chromium, atomic number 24. Let's write electronic configuration of chromium. 1s2, 2s2. Now why we are mentioning 2 electrons in S and 6 electron in P? Because we already know that S subshell can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. Okay, it's also mentioned in our lecture 4 part 1 in detail. You can check that. Then 2p6, then 3s2, 3p6, 4s2, and 3d4. 3d4 means 1, 2, 3, 4, 5 is if d orbital shows 5 orientation, 1 electron would be here, 1 would be here, 1 would be here, and 1 would be here. It means here d orbital is not partially filled. So from S, 1 electron would be shifted here. Then d orbital will have 5 electrons, and here will be 5 electrons, leaving behind 1 electron for S. Now how you will write electronic configuration of chromium? By writing D first and S later than D. We know that d orbital shows 5 orientations. Number 1, dxy, 2 is dyz, number 3 dzx, number 4 dx square minus dy square, and number 5 dz square. Then electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, then first 3d5, and then 4s1. Compare it with the electronic configuration of silicon. In silicon, as it's not the exceptional case, therefore we filled 4s first, followed by the filling of 3d. But as chromium is the exceptional case, therefore we filled 3d first, followed by the 4s. In 3d there are 5 electrons, and in 4s there is 1 electron, right? Okay students, in case of chromium, we just checked that all the orbitals in d subshell were partially filled. But now in case of palladium, let's see what will be the electronic configuration. In 1s, 2 electrons would be accommodated, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 3d8. But as according to rules, d orbital should be completely filled or partially filled. In case of chromium, we partially filled the d or d subshell. In case of palladium, let's see what would be the pattern. 5 orientations of d orbitals are there. 1, 2, 3, 4, 5. This is dxy, this is dzx, this is dyz, this is dx square minus dy square, and this last one is dz square. Okay, There are 8 electrons in D. 1, 2, 3, 4, 5, then 6, 7 and 8. It means these dx square minus y square and dz square are partially filled. We can only follow the pattern, either all orbitals must have one electron like partially filled, or all orbitals in d subshell are fully filled like 2 electrons in each orbital. So we can see that these 2 electrons from 2s, if we shift these 2 electrons from s to d, then total electrons in d subshell will become 10. Then number 9 electron would be here and number 10 is here. If these 2 electrons are now shifted to the d orbital 4d, it means 5s orbital will have 0 electrons. Then we can write the electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Then here 4d will be filled first, followed by 5s. Then 4d 10 electrons and 5s 0 electrons. This is the correct electronic configuration in case of palladium. Now what is your homework? Your homework is you just practice other exceptional cases. You can take any example from these exceptional cases and you can practice their electronic configuration. In case of any confusion, you can let me know in the comment box. After practicing the example, write it down in the comment box if the concept is clear or not. And do let me know that what topic you want me to discuss in our next class. I hope the concept is clear now. Okay, this is the end of this lecture. Take care of yourself. Stay blessed. Goodbye.